We have our solar nebula formed now, and here's what's happening with it. As that gas is trying to fall in towards the center of mass of all of this gas and move towards that larger blob in the center and add to it, it's trying to fall in towards the middle, but at the same time, it's also rotating around from that spinning that we described before. So as it tries to move in closer to the center, conservation of angular momentum is going to make it rotate faster and faster as it moves in towards the center. This works the same way as if you took a ball and attached a string to it and then twirled the ball around in a circle over your head using the string to move it around. But if you took your other hand on the other end of the string and pulled down on the string through the hand that's spinning the ball, then as the string gets shorter, the ball starts moving around faster. That is conservation of angular momentum. The ball has to increase its speed because you are decreasing that radius. So, as you rotate around the outside of the solar nebula and you want gravity to pull you in more towards the center, you're going to have to go around faster and faster as you move towards the center. So as the whole solar nebula tries to collapse down into a smaller solar nebula, the whole thing is going to start to rotate and spin faster and faster. And we're going to keep adding mass that'll make its way into the center and add to the middle part, and that middle part is eventually going to become a sun. So we are calling it a protosun. It's not there yet. It has not become a star. It's the beginnings of a star. So that's what a protosun is telling you. Also, we are adding more and more material to that. When you add more and more mass onto something, that process is called accretion. So the protosun in the middle is growing from accretion as more material makes its way towards the center. And then it falls onto that protosun and adds more matter to it, but also adds more energy to it. It's falling. It has kinetic energy, the energy of motion. What's going to happen to that energy when it hits that matter in the middle? It's going to add its energy to the matter that's in the middle, and adding that energy makes it energy in the form of heat. So our center blob, our protosun, is going to get bigger from accretion and also get hotter from the material that falls into it. Before we move on to the rest of our story for the solar nebula, I want to show you some photographs that we have taken through telescopes. These 4 pictures are actual photographs of something going on in space. This top thing is just what an artist is trying to show us how we think it would look if a solar nebula was forming. But in these pictures, we see something very bright in the center of a disk of gas. That means we're seeing a protosun in the middle of a solar nebula. Here we have evidence that we have found with our telescopes that this process actually takes place. This really works. Here is the scientific evidence that we would want to help back up our hypothesis and our theory. Now, if you take a look at these 4 pictures, you would probably, upon studying them carefully, realize that all 4 situations shown have 2 things in common. I'm not going to wait for you to raise your hand, so I'll just tell you. In each case, on one side of the solar nebula, it's brighter. See how it's bright? On one side, it's bright. And always on the opposite side, the second thing is, on the opposite side of the brightness, it has a tail. Bright, and then a tail. Bright, and then a tail. Bright, and then a tail. So these 2 things must go together. What is going on? Why are these things forming a tail? Are they moving through something and leaving a tail behind? No. Really, what's happening is off to the side of the picture where you can't see it, there are other stars that have already formed. They've become full stars that are burning fusion in their cores and now are shining out with a lot of brightness. And that brightness is light, photons, which come and hit these solar nebulas. In space, you can actually get an effective pressure from light that will push the molecules around. Light creates pressure. You didn't know that because when you turn on a light bulb, you don't get knocked across the room from the light. That's because there are other forces on Earth which are stronger to hold you in place. But in space, where you're a floating molecule, it's easy for the pressure from light to push you around. So when light comes from these other stars, then the light can push on the gases that have not yet been fully trapped into this solar nebula and can start to push them back out of the gravity of the solar nebula and push them back and away. So in all of these cases, there's something shining bright on one side of the solar nebula that pushes some of the gas back and away, pushing it back and away. Bright and then pushing it back and away. So we have actual scientific evidence that our solar nebula process so far has actual proof out in space.